Hello everyone, welcome to Gateway. In this video, we will be discussing about GATE Excel PYQs on the topic biochemical separation techniques. So each and every year we can expect around 1 to 3 questions from this topic. So let's start the video and move to the first question. So the question is, which of the following techniques can be used to separate proteins according to their molecular weights from a mixture of proteins? Okay, the options are ion exchange chromatography, size exclusion chromatography, SDS page, and sucrose density gradient chromatography. So in ion exchange chromatography, the separation is done on the basis of the charge of the molecules, not on the basis of molecular weight. So this option is not correct. Second option, size exclusion chromatography, as the name suggests, size exclusion. So in this chromatography, the separation is based on the size. Okay, so this is a correct answer. Also, this question is MSQ, so it can have more than one correct answer. Okay, so the third option is SDS page. In SDS page, the SDS, sodium dodecyl sulfate, provides a net negative charge on the molecules or the proteins. So when we run this protein sample on the gel, so the proteins are separated on the basis of the charge present on the proteins, which in turn is based on the size of the molecule. So this is also the correct answer, correct option basically. The fourth one is sucrose density gradient centrifugation. So this is a centrifugation which uses a density gradient, and when density gradient is used, the molecules are separated based on their weight, molecular weight. So this is also a correct answer. So the correct options for this question will be B, C, and D. Okay, hope it's clear. Let's move to the next question. So the next question is, a dye was allowed to undergo migration on a chromatographic paper using a solvent. The dye and the solvent front migrated 5 centimeter and 20 centimeter respectively from the point of origin. So the retention factor of the dye is, so basically there is one chromatographic paper, okay, and there is a solution. When this chromatographic paper is dipped into the solution, the dye as well as basically the solvent as well as the solute, which is the dye in this case, both start migrating on this chromatographic paper. But the migration of solvent is always more than the dye. Okay, so consider that the solvent has reached here, which is 20 centimeter, and the dye has migrated till here, which is 5 centimeter. So the question is asking, what is the retention factor for the dye? So there is a simple uh, uh, equation or simple formula for calculating retention factor, which is retention factor is equal to distance covered by dye upon distance covered by solvent front. Okay, dye front and solvent front. Okay, so here in this question, the dye has migrated 5 centimeter and the solvent has migrated 20 centimeter. So the answer is very easy, which is 0.25 centimeter. So the correct answer is 0.25 centimeters. Okay, hope it's clear. Let's move to the next question. So in this question, it's given that the absorbance of a 5 into 10 to the power minus 4 molar solution of tyrosine at 280 nanometer wavelength is 0.75. So in question it's given that there is a solution whose concentration is 5 into 10 to the power minus 4 molar, and the absorbance of this solution is given, which is 0.75. Okay, also the path length of the cuvette is 1 centimeter. So the path length which the light has traveled, which is denoted by L, is 1 centimeter. So the question is asking, what is the molar absorption coefficient of this solution? at this given wavelength. So the question is asking molar absorption coefficient, okay, which is denoted by epsilon. Okay, so this question is based on Beer-Lambert's law, and the Beer-Lambert's law tells that absorption is equal to, basically absorption is proportional to the concentration of the solution and the path length traveled by the light. So when we equate it, uh, one constant is added, which is molar absorption coefficient, and Cl. So absorption is equal to ECl. Okay, so here in the question, absorption is given, concentration is given, and path length is given. We have to find out the molar absorption coefficient, which is epsilon. Okay, so epsilon is equal to A upon Cl. We just have to put the values. So A is given as 0.75, concentration is 5 into 10 to the power minus 4, and path length is 1 centimeter. So we just have to solve it. 5.15, so 0.15 we will take it above, so it will become 10 to the power 4, so it will become 1500 per molar per centimeter. So the answer is 1500. Okay, I hope it's clear. Let's move to the next question. So the question is saying purification of 6 his tagged protein using NINTA column is an example of. So what is his tag? Basically, if there is a protein, so generally a tag is added on this protein for this identification. In this case, it is 6 histidine molecules, and the column is NINTA column, which has in its stationary phase can recognize this his tag protein, okay, which can be attached to this stationary phase, and rest of the molecules or proteins can elute out. So this mechanism or this property is known as affinity. So this is affinity chromatography. Okay, I hope it's clear. Let's move to the next question. The stationary phase used in gel filtration chromatography is composed of blue dextran, CM cellulose, DEA cellulose, or saccharose. So the question is asking what is the stationary phase of gel filtration chromatography. Gel filtration chromatography is also known as size exclusion chromatography. Okay, so blue dextran is not used as a stationary phase. Blue dextran is generally used in affinity chromatography and also in size exclusion, but not as a stationary phase. CM cellulose, it is a negatively charged molecule which is used as a stationary phase in ion exchange chromatography. Okay, so this option is also incorrect. DEA cellulose is a positively charged molecule which is also used in ion exchange chromatography. So this option is also incorrect. So the correct answer is saccharose. Okay, let's move to the next question. With respect to STS, which of the following statements are true? So this question is a MSQ question. So the question is asking which are the true statements regarding to STS page. So the first option is ethidium bromide is used to track the progress of electrophoretic mobility. Okay, so consider this. So this is a gel. This is the negatively charged electrode, which is cathode, and this is the positively charged electrode, which is anode. Okay, so these are the wells where the protein samples are added, and these protein samples run on this gel. Okay, so the first statement is ethidium bromide is used to track the progress of electrophoretic mobility, which is incorrect. Why? Because ethidium bromide cannot be seen with naked eyes. When we expose this ethidium bromide with UV, then only we can visualize it. Okay, so we cannot use ethidium bromide to track the progress of electrophoretic mobility, and for this function dyes are used. Okay, next option, Beta mercapta ethanol is used to reduce disulfide bonds. Yes, it is correct. Beta mercapta ethanol is a chemical which is used to reduce the disulfide bonds. So this statement is correct. So next statement, the protein migrates towards the anode. Protein migrates towards the anode. As we can see, anode is the positive charge and the proteins are migrating towards the anode, which is correct option. Last statement is the lower molecular weight protein migrates slower than the larger molecular weight protein. So the question is telling that the larger molecular weight protein migrates further and the smallest, lowest molecular weight proteins migrate the least. But this is incorrect. This is not the case. The um, the protein with largest molecular weight is the one which moves the least, and the lowest molecular weight protein is the one which migrates the most. So this is the correct scenario basically. So this option D is also wrong. So the correct answer for this question will be option B and C. If you like this video, please subscribe to my channel. Thank you.